Hello everyone. So we're back in another video. So in the last video we've done a few exercises on the inverse of a function. We can get the inverse of a function using the straightforward approach if it's a 2 by 2 matrix. So in that case we just do the so we have both diagonals. We multiply and subtract one from the other. And of course we change the location and the signs on each. So that's if we have 2 by 2 matrix. But if we have more, then we will have to use another approach, which is called multiplication by the identity matrix. And you do the Gaussian Jordan-Gaussian elimination to suffice to at least reach the identity matrix. The resulting matrix would be the inverse of the matrix we're working on. And we've done a few exercises on this, but I'll just add an Anki to this. I'm not sure how to write a matrix with lattice matrix. Let's see if this actually how to write matrices in lattice. Let's see if this works. It's pretty complicated if you do ask me. So A, B, C, D, begin, end. Well, it's pretty tough stuff. Well, sometimes learning or picking up a new thing is pretty interesting. Sometimes it has its own share of. So instead of us going through, having to do Anki for this, what we can do is we could add this to Anki. So the determinant is one approach. If it's 2 by 2, it has to be 2 by 2. I just want to confirm that that is 2 by 2. Like a 1. I think we need to identity matrix. It's very important to keep things properly documented for easier revision later on. Anyway, so that's the case with inverse, and let's see what we have. So in the last video, if I'm not mistaken, we decided that we will be covering a bit more topics on. So we've done a bit of exercises on this one. So the next topic to cover would be, so if this is the inverse of a matrix using elementary row operations, inverse of a matrix using minors, cofactors, and adjugate. Sorry. Okay, so we can calculate the matrix of minus, then turn that into the matrix of cofactors, and the adjugate, and multiply it by 1 over the determinant. So, but it's best explained by working through an example. So let's see what they're offering here. So we've seen two methods to get the inverse of a matrix. Let's see how is it obtained otherwise if we did not use the determinant, and well, if it's not a 2 by 2 and we decided not to use the Gaussian elimination. So find the inverse of A. It needs 4 steps. It is also simple arithmetic, but there is a lot of it, so try not to make a mistake. Yeah. The first step is to create a matrix of minus. This step has the most calculations. For each element of the matrix, ignore the values on the current row and column. Okay, we need to keep things properly documented here. Okay, so this is has to go down a bit. So what is called minus cofactors and adjugate. Minus factors minus cofactors minus cofactors. Okay, so we have a matrix here. That was matrix of minus. We generate what is called a matrix of minus. It needs 4 steps. Okay, so step 1, matrix of minus cofactors and adjugate. Step 2, matrix of cofactors multiplied by half of adjugate, also called adjoints. Should also add this while we determine it. So this could be you could color this orange, orange, and orange. So these are the different things we need to color. Okay, so let's see what they're doing. The first step is to create a matrix of minus. This step has the most calculations. For each element of the matrix, so we have 3, 2, 0, 0, 0, 1. Okay, ignore the values of the current row and column. So we are here, so we ignore 302 and 320. So we should only work with 0, minus 2, and 1 and 1. Calculate the determinant of the remaining values. So in this case, we calculate the values of 0 multiplied by 1 minus minus plus 2. That's the determinant. Okay, put those determinants into a matrix, the matrix of minus. 2 rows and 2 columns, the determinant is easy. AD minus BC. Think of a cross. Minus BC, I've done that. It gets harder for 3, etc. The calculations, yeah, the first 2 and last 2 calculations of the matrix of minus. So what we need to do is we need to move from one to the next, one to the other, and calculate the oh, that's a really long thing to do. There's the calculation of the whole matrix. So we've got this. So we've got this is 2, 2, and all the way to negative 10 and 0, matrix of minus, matrix of cofactors. This is easy, just apply a checkboard minuses to the matrix of, in other words, we need to change the sign of alternate. Yeah, every other, we change the sign of every other element. Okay. Adjugate, now transpose. You will have 2, negative 2, 2, negative 2. So this would be here, here, here. So this is all transposed. Multiplied by 1 over the determinant. So now find the determinant of the original matrix. This isn't too hard because we've already calculated the determinant of smaller parts when we use matrix of minus. In practice, you just multiply each of the top row elements by the cofactor in the same location. So we've got the matrix 2, 2, 0, and that's that. And then we need to, so it's the 3 comes the top row, comes the top row. So the first row elements of the top row. So what is he doing here? So he calculated the this is a 2, and then we have another 2. So it's 2, 2. We have the first row, so 2 multiplied first row. So this would be 3 by 2 plus the original matrix we had, which is 0, 0 multiplied by 2, another 2. Is it 2? Yeah, it's this one, and then still should be 4. Why are you talking about 0? But it's the original matrix 0 multiplied by 2. This is a little bit this is not an easy way to do it. Okay, so Adjugate. I really think this approach is a little confusing. It's a little hectic. Here's how it works. Bookmark. So you need to have a separator here. Made to divider. Is it divider? Separator. No. Yeah, spelling is dead wrong. We could add this here. Yeah. There we are. It's a little, I don't think it's really that effective, but since we can achieve the same using, it's exactly the same for larger matrix, such as 4x4, but whoa, there's a lot of calculation involved to calculate 16 determinants, so it's often easier to use computers. Yeah, I'm not even sure if going for this approach could be any good. It's interesting. So we can transpose a So we could go like 6, we could go 9, we transpose it, B transpose it, A to P, inverse of A. That would be interesting to, let's do an inverse of A. Sure. So the inverse. Inverse. What? Why is it determinant 0 here? And this is 0, man. Come on. I could set this as 0. Interesting. Anyway, so I don't think we really should dive more into this because it's a bit long. It involves lots of steps, and it's easier to just go for the identity matrix. But just a quick recap on how they've done this, just for the to refresh our memory for the next time we ever come across such an implementation. Anyway, so what we are aware of is that when we have a matrix, we need to work with, so from the titles, minus, cofactors, and adjugate, and you multiply by 1 over the determinant. So with minus, what the minus means is that you take each row and column, you work with the first row, and then you ditch everything that is in that below that row and that column. So you'll be working with the remaining values. And you will be calculating the determinant for the remaining values. So you'll have those determinants, and then you would multiply those determinants by each of the rows, I believe, yeah. Yeah. So you have the original matrix of 3, 0, 2, 3, 0, 2. So each of the values here would be the determinants. This is the determinant of matrix, and then you would change the sign on each of these values, and then you transpose, and then you multiply by. So it's not like you would be multiplying the. So this is just a matrix of determinants, as you call it. Yeah. So like in this case, we take the determinant, put it here. That's 2. And then we take this one, take the determinant, put it here. Here, take these, put it here. And this one, you ignore these and these, and you take these. And then so on and so forth. You put the end result in a matrix on its own and change the signs of each and every one. You just change the signs. Well, you don't have to really change the signs. It's just that change the sign of each and every one. So each one there is a different sign. Check put a sign, and then you would calculate the determinant. Of course, you do the transpose and then find the determinant of the original matrix, which is just the first row, and they multiply it by the each and every one minus plus. I don't know how they're done, but we can always refer back to it if we ever need to. Then you multiply it, and then you get the inverse. Well, it's really hectic process, and you can easily mistake things along the way. So let's go directly to the conclusion and see what they say. So for each element, calculate the determinant of values not in the row or column to make matrix of minus. Apply check both of minuses to make the matrix cofactors. Transpose to make the adjugate, and then we multiply by 1 over determinant to make the inverse. I don't know. Should we really concern ourselves with that? So I don't think we should. I don't think we should do the exercises too. It would really take a long time. And I really don't think we should be doing any more of this because we've already done the inverse using the identity matrix, and that really suffices everything we do. And for a 2 by 2, we've already know 1 over the determinant multiplied by the matrix, and then you change whatever you need to inverse, right? And that's about it. So we'll just move on to the next part now, which is, well, I guess I'll just end this video here. And so the next bit of, so we've done the multiplication of matrices. We determinant of a matrix, we've already seen that for a 2 by 2. So yep, for a 2 by 2. Oh no, we didn't do the for 3 by 3 matrix, the determinant. How do we calculate the determinant? That should be in the next video. We didn't do this one, did we? Interesting. Alright, cool. So this is it for this video. Cheers.